In chapter 5, we will continue the time value of money with multiple compounding and also for multiple cash flows. After this chapter, you should understand the difference between annual percentage rate or APR and the effective annual rate or EAR. And you should be able to compute the future value and the present value of multiple cash flows. Multiple cash flows are basically a type of cash flows related to one investment. So you have to include all cash flows when you evaluate present value and future value of these cash flows. And there are special types of cash flows. Perpetuity is when cash flow occurs at the same interval forever. And annuity is a type of cash flow occurring at the same interval for a finite time period. So we will try to see how we calculate present value and future value of these special types of cash flows. And then you will understand how loans are amortized or paid off, especially loans with the same payment, like car loans or mortgages. So we'll try to understand how these loans are amortized. Let's first look at the effect of compounding other than annual compounding with an example. So suppose you deposit $500 into an account that has an APR. So APR is the annual percentage rate, or what is coded as the legal interest rate for any type of account or loan. But it is based on monthly compounding. So monthly compounding means instead of paying interest once a year at 9%, you divide 9% into 12 and pay interest every month. That means if you receive interest on your original $500 in the first month, that interest on your original investment can earn additional interest next month and so on. So how much will you have in an account in 35 years? Let's think about 1 year from 0 to 1, and it goes up to 35 years. And usually annual compounding means it pays 9% at the end of the year. But monthly compounding means you divide this into 12 time periods and you pay 9% divided by 12 every month. So there will be 12 times interest payment, and the overall return will be different. It will be actually greater than 9%. So here's original $500 investment, then 500 times 1 plus 9% divided by 12 will be your return after a month. And after second month, you will earn additional 0.09 over 12 much interest rate. So and so on. So you will do this for 12 times over the year. And so at the end of the year, first year, you will have 1 plus 0.09 divided by 12. So basically this is a monthly interest rate compounded 12 times. And you have 35 years, so you will do this 35 times. So instead of compounding 9% for 35 times, you're compounding monthly rate by 12 times 35 times. So you can see the effect will be quite different. So if you calculate this, you will have 11,531.69. if you compare this with the annual compounding at 9% for 35 years, it will be 10,206.98. And you can see the more you compound, you have a larger amount at the end of the investment horizon. Now let me show you how to do this in Excel spreadsheet. With the annual compounding, as we did before, for future value, the interest rate 9%, 35 years, no other payment, and negative $500 present value. So we have this future value, and with the monthly compounding, future value with monthly rate, which is 9% divided by 12, and the number of periods 12 times 35, no other payments, and negative $500 present value. So here you should understand that you have to adjust the interest rate and also the time periods according to the monthly compounding. So here's another example with daily compounding. You need $15,000, so this will be future value you need in 3 years. And if you can deposit money into an account that pays APR of 5.5%, so this is annual rate based on daily compounding, but APR will be divided by number of days in a year and how much would you need to deposit. So if we write the formula, it will be present value of $15,000 divided by 1 plus daily rate, which should be APR divided by 365 raised by 365. So this is the annual discount rate, but we're talking about 3 years, so you multiply by 3. So this gives you the present value. Again, let's look at this on Excel spreadsheet. So with daily compounding, present value with interest rate 0.055, APR divided by 365, and number of periods 365 times 3 years, and no other payment, and future value 15,000. Here's another example. You will be starting your graduate studies after 5 years, and you estimated you will need $40,000 at that time to put you through graduate college. And your bank is offering an annual rate of 6.5% compounded weekly. Remember, in a week we have 52 weeks a year. Alternatively, you can invest in a fund offering 7% compounded every quarter. So this is a quarterly, 4 quarters per year. Which alternative should you choose to invest and why? And there are several ways to compare this. First of all, you can just simply calculate the present value of your money you need. So the present value of 40,000 discounted at annual percentage rate 0.065 divided by week to account for the weekly compounding, 52 times 5. So this gives you the present value of 40,000, calculating how much you need to invest. So that's first alternative. And the second alternative, again for same amount, you will discount at 7% APR compounded quarterly. and quarter number of quarters times 5 again for 5 years, and whichever gives you lower amount will be the better investment opportunity. So that's one way. And another way to compare these two is simply you calculate what is the effective annual rate. Effective annual rate is the actual rate of return after you account for the different compounding. So if you compound 6.5% weekly and compound 7% quarterly, then whichever gives you higher EAR will be the better investment opportunity. So either you choose lower present value or higher EAR. So we'll discuss about EAR in the next slide. So first let me show you how to do this calculation in Excel. So first, present value with the weekly, we have present value of 0.065 divided by 52 for 52 weeks per year times 5, no other payment, for a future value of $40,000. So that gives you $28,906.96. And present value with quarterly, you will have present value of 0.07 divided by 4 quarter, and 4 times 5 years, no other payment, for $40,000. And you can see this gives you lower present value. With the quarterly compounding, you have lower present value, so this is the better investment opportunity. And if we calculate effective annual rate, which we will discuss in the next slide, effect is given as APR 0.065, and number of periods is weekly 52, and you have 6.712, which is lower than even 7%. And with 7%, the number of periods 4 for 4 quarters, and you have 7.2%. So this alternative has lower present value or higher effective annual rate. So this should be the better investment opportunity. So APR is the annual percentage rate based on simple interest payment. So in other words, this doesn't consider compounding effect. So by definition, APR is equal to period rate times the number of periods per year, because it is simply annual percentage rate. And EAR, or effective annual rate, is the actual rate of return paid or received after accounting for compounding effect. So EAR is given as 1 plus APR, annual percentage rate, divided by number of compounding, M. It is 52 if it is weekly compounding, and raised by M, again, number of compounding, minus 1. So this gives you actual rate of return or effective annual return that you are earning with the compounding effect included. And in Excel, as I have shown you in the previous example, you will use an effect function with the nominal rate, or APR, with the number of compounding per year.